In this video, we will look at the patterns for properly squaring a binomial. So let's look at our first example. We have to find the square of the binomial x plus 3, or x plus 3 quantity squared. So if we break it down, think about what it means to square any quantity. It means you take that quantity and multiply it by itself. So since I'm squaring the binomial x plus 3, I could think of this as the product of x plus 3 times x plus 3. Now, I don't have to use the pattern. The pattern is more efficient later on. You'll see that. But for right now, I could just distribute and use the distributive property, or what some of us like to refer to as the FOIL method, F-O-I-L. So first I'll multiply x times x and get x squared. Then I will multiply 3 times x to get x squared plus 3x. Then I will multiply 3 by x again, so I will get another plus 3x term. And then last but not least, I will multiply 3 times 3 to arrive at plus 9. Now, I do need to combine my like terms. So in the middle, I have like terms, positive 3x plus 3x. So my final simplified polynomial becomes x squared plus 6x plus 9. So that was just fine. I could have got my simplified result that way. But down the road, you're going to want a more efficient path to your simplified answer. So we're going to use the formula. So we're going to compare our original expression, x plus 3 quantity squared. We're going to compare it to a plus b quantity squared. So if I look at x plus 3 quantity squared, my a value is x and my b value is 3. So what I'm going to do is I'm going to use that formula and substitute x for the a value. So I'm going to have x squared plus 2 times the a value, which is x, times the b value, which is 3, and then plus the b value squared, so plus 3 squared. So simplified, I get x squared. Now in the middle, 2 times x times 3, well, that's positive 6x, and then at the end, 3 squared is 9. So you see we arrive at the same simplified result. Let's take a look at our next example, and we're just going to use the formula for this one. So if you want to pause the video and think of it as 3x minus 5 times the binomial 3x minus 5, and if you want to do the distributive property, go ahead, but then come back and try the pattern. Okay, so now we're going to use the value 3x as our a value. Now, our b value is just 5. I know a lot of times we want to say, oh, well, shouldn't the b value be negative 5 because it's minus 5? But no, we don't need to do that because remember, there's a whole nother equation for when we have a subtraction inside of our binomial. So if we have a difference in our binomial, then we'll use the second version of the formula. So I'm going to use the formula where it tells me to do a squared minus 2 times the a times the b value. So that's why there's no need to make the b become negative 5. Just put the minus in where the formula tells you. And then you always add at the end because you're squaring that number. So it's always going to be positive whenever you square a number. So now let's fill in the blanks. So a squared, I'm going to replace a with 3x minus 2 times a, which is 3x, times b, which is just 5, and then plus my 5 squared. Now let's simplify. So the term 3x, when I square it, is 9x squared. Now I'm going to subtract the product of 2 times 3x times 5. Well, 2 times 3x is 6x, and then times 5 is 30x. So now I have 9x squared minus 30x, and then I just add 25 for 5 squared. So you should arrive at the same answer whether you perform the binomial 3x minus 5 times itself or whether you use the pattern.